Okay, what about now the second part of the lesson? Don't forget that our lesson is talking about infinity, whether it's an answer or x approaches infinity. But what about these types of questions? 1 over x minus 2. This is a rational function, remember? And there is an asymptote line. I know that the vertical asymptote line, by looking at it, it's the x equals to 2. And as you can see, limit is actually asking to study the x approaches the two left and right, which means approaches the asymptote line left and right. So in this case, what do we need in these types of questions if we saw a rational function like this? A rational function like this with a specific answer or a specific x approaches to a 2, which is the asymptote line, we should do 3 steps. The first step, the domain. All real numbers except this 2. Next step, vertical asymptote line is x is equal to 2. Next step, table. It's up to you. You want to graph or put the table, both of them will be fine. The most important thing, why the graphing? To see from the right to this 2 and approaches from the left to this 2 is going where? As you can see, from the right it's a positive infinity, and from the left it's a negative infinity, which means that these two are not equal. Once these two are not equal, it does not exist. Another example about the same idea. Also, rational function, as you can see, x approaches to a specific number. So once we see a rational function, now you are asking yourself, why now? Why to study? Why to graph? Why to find the domain? It's as simple as this, because it's a rational function. Rational function, and I can tell that the x approaches to the vertical asymptote line. So the first step, I did the domain. Second step, like I told you, table or the graph does not matter. But when I graph it, I can find out that the graph approaches to this x is equal to 2. From the right is going to positive infinity, and from the left also is going to positive infinity. What does that mean? The limit of f of x as x approaches the 2 equals to positive infinity.